Welcome, everyone. Thank you for joining us for today's webinar. My name is Juliette Sigmund, and I'm your host today for our inaugural Megaport Live webinar series. Today's topic is how to optimize hybrid cloud networking, presented by two of Megaport's finest, Misha Cetrone and Kevin Dresser. Just a little housekeeping before we get started. We are recording today's webinar, and we will post the recording to our website shortly. We will have all our participants on mute today for the duration of the webinar, so please use the Q&A panel to ask your questions. The Q&A panel is located at the bottom of your Zoom screen. You can type questions in at any time during the webinar, and we will address them at the end of the presentation during our Q&A segment. If you experience any issues with the Zoom interface, try logging out and back in. If that does not resolve your issue, please contact Zoom via the help window on the top of your toolbar. Now, without further ado, I'll hand it over to our presenters. Thank you.
Awesome. Thanks, Juliette. So just for anybody that's just now joining, hey, everyone, Misha Cetrone here, VP Strategic Partnerships. I'm also joined by Kevin Dresser, Senior Solutions Architect. We're going to be discussing and demonstrating how to optimize real-world hybrid cloud applications with network connectivity. Kevin, how's it going?
I'm doing well, Misha, and really excited to be here and appreciate everyone joining, and really hope that by the end of the session today, you all realize how powerful some of this network technology is that Megaport has, and hopefully how you can actually use it for some real world use cases.
Excellent. Well, let's go ahead and jump into the first slide. So to start, everyone, we're going to look into some leading network challenges and trends for enterprise cloud strategy. So thinking about what factors to consider in optimizing connectivity to essentially run hybrid cloud environments. So what you see on the screen for us to start is some leading insights with some IT research analysts. And there's a collective here. So there's several: Enterprise Strategy Group, Flexera, as well as Checkpoint. And all of these are data points that came from their survey with IT leaders responding as part of that survey. And these are really compelling for us as we're going to discuss how to solve some of these pain points. So just starting around network costs, 86% of organizations state that cloud initiatives are hindered by networking costs. So we're going to look at ways that you can improve network spend. We're going to look at how you can right-size connections with technologies like software-defined networking and deploy more of a consumption-based model, not just for cloud, but for your actual network. 60% of organizations will use 4 or more cloud providers. This can be a combination of running both public and private cloud workloads. There's different types of CSPs that are going to have different types of services that can drive even, a lot of complexity around how you're managing those. So we're going to uncover how you can simplify the sourcing, orchestration, and the deployment of these services with cloud. 77% of organizations report network issues multiple times per week, not a month, but actually per week. So we find that to be pretty compelling as well. Some of these issues can arise from things that are predictable. It could be bursty traffic. So we want to also look at uncovering ways to deploy agile solutions, right? And how you're optimizing traffic, how you're able to mitigate downtime, thinking about availability. Do you have access to additional capacity? You will absolutely be able to do that as we look at some of these architectures and we showcase this demo. 57%, let me get this button off my screen. It's covering up the presentation. I apologize. There it is. 57% of organizations are migrating more applications to the cloud. So as more applications and data are being migrated, let's say, for example, from on-prem to public cloud environments, and also there's opportunities to downsize certain workloads and data stacks from public clouds back into more of a private co-located environment. It really comes down to your business needs, your operation, and your best practices. So this is both from a cloud-first approach methodology, but also if you're a data-first organization, we're going to discuss how you can leverage SDN to enhance any of these different methods. 59% of organizations use optimizing existing use of cloud. So thinking about cost efficiencies, right? This is very important as leading business drivers. We're also going to talk about how to take advantage of cloud data transfer charges and the flexibility that software-defined networking can bring for your interconnection to manage TCO, your total cost of ownership. And then last but not least, 38% year-over-year increase in cyber attacks. This is really concerning. We want to look at ways that you can harden your attack surface. We want to be able to remove risk of malicious attacks that can lead to negative impacts, not only to your business, but to your users. So these are all things that we think are pain points that should be considered as part of your network planning, regardless of where you're at with your cloud journey and running hybrid cloud workloads. And this is the stuff that we're going to showcase as we go through the demo. So all key themes here that are critical to consider. And then Kevin, let's jump into the first visual. We're going to look at a traditional common network deployment as the base for what IT organizations could consider when coming from this thing called a private cloud network data center environment. Kevin, why don't you join in and let's share with us your thoughts on this overall architecture.
Yeah. And just to kind of recap a couple things, previous roles I've had in working with customers and their transition to cloud, whether it's multi-cloud, hybrid cloud, sometimes that going through that process really exposes how critical the underlying network is. Because if you look at this, traditional architecture, private cloud, you've got your application and data stack sitting in a data center, and you've built your network architecture around that, right? So connecting your remote sites, remote users, your headquarters, your branches, and leveraging, internet connectivity, potentially using, secure VPNs, but also private connectivity, typically with an MPLS type of transport. And one of the benefits of this architecture, when you look at the data center is, you can take advantage of all that high speed LAN connectivity that's supporting workload to workload traffic, applications communicating with databases, backups, replication, those sort of workflows. And also considering your security architecture, building that, supporting this, and taking this platform, and then now moving it to what we call a hybrid cloud architecture, it's pretty disruptive. And, specifically around the fact that now you've taken certain applications, some workloads, some data stacks, and pulled them out of your private cloud to take advantage of optimization, not just for compute, storage, performance, and scalability, but also for costs. And you're definitely going to have reasons for maintaining your private cloud infrastructure, whether it's on-prem or in a colo facility. There's multiple reasons for that. It could be regulatory reasons. It could be proprietary hardware, things like that. So the private cloud component is just as critical here, but also take into consideration, getting from the edge to those cloud environments, right? All these edge locations, sites, headquarters, remote users. Now you've taken that sort of, just building around for that private cloud platform, but now you've got to build it to your cloud providers, AWS, Azure. And, I'm showing an example here of a private connection deployed to AWS using a direct connect. And whether or not your existing MPLS WAN architecture can support that easily is one of the biggest challenges that IT organizations first encounter when they realize, all right, I need a private connection. If my MPLS carrier can't deliver that connection to the optimal location, sometimes I have to look into using a Metro E or point-to-point, other types of private connectivity, and land it in a cloud exchange data center. And just going through that process can be, it can take a lot of time. It can take a lot of resources. In some cases, you may have to deploy hardware in cloud exchange data centers that you weren't anticipating as part of this deployment. So, what are some of the things that can help solve some of these challenges? We're gonna start looking at, all the advantages of cloud computing and the scalability, and being able to, apply that same concept to the underlying network is really critical to being able to support your hybrid cloud architecture.
Yeah, absolutely. And I think as we consider this hybrid cloud approach, there's some additional insights here across both network performance and even operational aspects that we want to touch on before we get into, okay, what are you going to do about this? So this is where variable demand can really impact your user's experience and your organization's bottom line. So thinking about how elastic is your network to handle the following challenges. And this is part of an enterprise strategy group survey as well. So looking at 28% of organizations indicated network problems are a result of unpredictable bursts of network traffic. So how you manage this unpredictability to make adjustments in real time, it becomes critical. So leveraging the flexibility of what we're going to go over in software-defined networking can allow you to make those necessary adjustments for bursty traffic flows. 50% of organizations stated problems are caused by predictable but temporary demands of network traffic. So being able to handle seasonality is a leading example here. So thinking about, we don't want to waste unnecessary capacity and pay for it that is only needed during peak times. So thinking about how can you dial up and dial down network bandwidth becomes essential. 22% reported systemic problems that constantly outpace network capacity. So to Kevin's point earlier about the scale and the agility of what you have available for your network, as you're moving to more cloud-like capabilities that have scale and have agility, you need that for your interconnection strategy. So having the ability to do that with software-defined networking on demand and managed capacity is really important. That can be turned up in real time to avoid these systemic problems. And then even using API automation to manage certain thresholds. All this can help support time objectives. So thinking about your disaster recovery requirements, right? SLA performance levels being honored, capacity cost optimization, and then the scale based on your user traffic demand. This can all be established with software-defined networking. And as we move into showcasing solutions in this next visual, we're going to discuss just that. If you want to move into the next slide, Kev.
Yeah, and so let's look here now. Similar architecture diagram that I showed before with the hybrid cloud, but what's different here is, let's focus on what this middle mile is and what it's all about, and the role that Megaport plays here. So, one of the key things is, or that customers realize is, all right, I've traditionally, the middle mile, I was just relying on my service provider for it. I had a handoff, they took care of everything. For the most part, it did its job. But now with dealing with cloud connectivity and the requirements to be agile, having control over that middle mile and being able to leverage a software-defined network to actually build the connectivity is really what we're talking about here. And, at the end of the day, Megaport has a physical network deployed across the globe in data centers that's interconnected with physical fiber connections, not only between those data centers, but to these cloud provider NNIs. So taking away having to deal with any of that physical infrastructure, but actually being able to control it through the software-defined platform is really where this network as a service concept is aligned with, cloud service provider services, right? So being able to deploy compute and storage as needed in a specific data center, having availability zones, which is essentially, a physical data center resiliency. And those same concepts now apply to Megaport's physical network that's inherently resilient, but also deployed in multiple data centers across the globe. And now being able to build connections through that software-defined platform is really, some of the key things that are changing the game, because it's not necessarily just having the advantages of an SLA-backed network that's going to guarantee bandwidth, uptime, and even latency. But there's also some cost savings when you start looking at what the CSPs call cloud egress fees. There's some significant savings that can be realized depending on your workloads and how data is moving in and out of the clouds. And when you're trying to do this with internet connections, those egress costs are significantly more. And being able to take advantage of actually using both methods of transport, internet for some cases, but a private backbone for other cases, really, now extends the underlay for a lot of the SD-WAN technologies that most organizations are, familiar with. and now have control of that, private underlay that they can actually align and leverage to have their SD-WAN platforms become more efficient.
Absolutely. Well, I think, Kev, why don't we jump into your visual representation of what we're going to discuss in the demo itself.
Yeah, so here's what I'm going to actually build on the Megaport portal. So let's look at the actual customer environment, and in this example they have a private cloud infrastructure hosted at a data center in Dallas, but they've deployed workloads in Azure and AWS. So really, to build private connectivity between all three locations using Megaport's platform, we're gonna deploy two of Megaport's access services. One is called the port, and one is called the Megaport Cloud Router. And just to point out, the connections to the cloud using the actual port can be done. In this diagram, I'm showing the connection from the port to the cloud router and then to the cloud environments. But a customer could build these, what we call a VXC, directly to the cloud environments. But the reason we're incorporating the Megaport Cloud Router is when you look at the geographic proximity and the traffic flow and the design architecture requirements, having the Megaport Cloud Router solves the problem of latency between those clouds. And because the AWS and Azure environments are physically hosted in the Northern Virginia region, that cloud router is also hosted there. So traffic going from Azure to AWS is going to be optimized. Doesn't have to come all the way back to Dallas, but traffic that needs to go back to that private cloud can go from that cloud router to the Megaport, which is tied into the customer router. So point is that there's a lot of flexibility with building what we call these virtual cross connects and leveraging both the ports and the MCRs. But what I'm going to do now is actually jump right into our portal to show, how quickly this can be done.
Yeah, and right before you jump into the console, Kevin, if you don't mind, specific to this diagram, everyone, to Kevin's point, that example of Northern Virginia, it's the same scenario whether or not you're using a separate cloud region. We're going to have on-ramps to all these major cloud destinations in US East 1, East 2, West 2, and even in central regions. So you can use those local native virtual appliances on our fabric. And we treat those as virtual network functions. The other great thing is that even in the scenario where we're combining both what we call the ports, which is essentially the layer 2 physical trunk port that you can connect to, and we virtualize your connectivity, you can connect it to that cloud router. But if you have your own network hardware in your on-premise environment, in your co-location environment, you absolutely can use that as well. So you have control, you have choice. If you want to continue to virtualize network functions using our purpose-built fabric for that, you absolutely can. And it's all on demand and all being managed by us.
Yeah, those are great points there, Misha. Thanks.
Sure.
Okay, so why don't I now jump into our portal here? So, as I mentioned, we've got access methods to get onto our network. We've got the port, the MCR, and what we call the Megaport Virtual Edge. In this case, I'm going to first run through the creation of a port. So I'm just simply going to say create port, and I'm going to drill down and select my actual location, starting by the country, and then drill down to a specific city or region. And based on where my private cloud is physically hosted, I'm going to select the Digital Realty Data Center in Dallas, choose next. And then, so here's where I'm going to, define the parameters for that physical connection to Megaport's network infrastructure. So first thing I'm going to do is select this port speed. And in this case, I've got three options. I'm going to choose 10 gig. Next thing, I'm just going to give it a name. This is just a logical name that's going to be associated with this particular service in the portal. Then I have the option of making this port private or public. We can cover that a little bit later on, but essentially what that means is if I make it public, then me as a business or a service provider, I can share that out and make it accessible so that other organizations can actually connect to my network and the process for doing that is what we call our marketplace.
Yeah, it's actually really good. There's really good use cases for B2B. So for business to business that want to interconnect directly, they can. And if you want to opt in and expose yourself, if you are, say, outside of just an enterprise, you're a service provider, then you're opting in and exposing publicly for other folks to be able to potentially connect to you over our fabric. So there's wide, very different use cases for that, but you get the choice to keep it private or public.
Okay. And then, so next thing here is I can actually, for the port service specifically, I can specify a month, or I can actually look at different terms to, take advantage of certain discounts that might be available. The next thing I want to cover here is port diversity. I'm going to just do a single port, but we do have what we call diversity. So if I want to build a high availability type connection to Megaport, I can do that through 2 physical cross connects landing on separate Megaport network devices. So that can be done with what we call port diversity. I'm going to just leave this alone as a single connection, but the other element too, if you are going to do port diversity, you can actually use technology like link aggregation control protocol and actually aggregate the connections between your physical hardware and the Megaport interfaces. So now that I've set these parameters, I'm just going to choose next. It's going to confirm what it is I've actually ordered. I'm going to click on add port. And I'm going to commit the order and order. The deployment process is now kicked off. But before I show the Megaport Cloud Router deployment, I just want to point out that everything I just walked through and what I'm going to walk through for the rest of this demo can also be done through our API integration. So we expose our APIs so that customers can actually leverage automation tools. So things like, maybe Terraform providers, we've got actual documentation and Terraform provider scripts that customers can use to now manage their network connectivity. So if you think about what most customers are doing already in their cloud environments with automation, they can now think about the automation capabilities that they're using for those cloud environments. They can also now extend that to the network. And that really comes to play with, what we talked about before with the elasticity. If at the end of the month, you've got a lot more workload resources that need to be deployed, and the network is also going to require more bandwidth, you can actually, build that into your automation to not only boost up the cloud workloads, but also boost up the bandwidth that's interconnecting those different environments.
Yeah, it's such a great point, Kevin. I think around that whole variable demand component and network performance in your operations, how you're able to automate things. And we all know that more DevOps personnel are participating into the network now. And as they're building and running apps, they're also looking at ways to automate and script out the ability to manage the connectivity that's handling each unique workload. So it's really powerful that you can use our Terraform provider scripts that are out there today and source our API.
Yeah, and when I'm gonna now select the MCR and deploy that. As far as the process goes, again, we're going to drill down to our particular region. I know that Northern Virginia is where I want to deploy my Megaport Cloud Router. So you can see I've got one location I can choose in Reston, Virginia, the other one in Ashburn, Virginia. But again, this kind of just shows from a diversity and, the concept of an availability zone. When I want to start looking at a high availability architecture, this shows right here that I can deploy these services within a metro region, but at different physical data centers. Which is really important when it comes to being able to mitigate, disasters, whether it's, not necessarily disasters, but even planned or unplanned downtime. So getting back to the Megaport Cloud Router, as far as the bandwidth specs, we have 4 different options that we can choose from this virtual network router. I'm going to choose 1 gig here. Again, I'm going to give it a name. This is just the logical name that's going to show up in my portal. Again, the terms, I'm going to do no minimum term. And then the last thing I have to set is my ASN number. Now, Megaport actually by default is going to put their ASN in there. And for some customers, that's a big benefit because some of the different types of peering that you may be doing with a cloud provider may be using public peering versus private peering. If a customer doesn't have their own ASN, this can really come into play and be a huge benefit. But based on my architecture here for my enterprise network, I want to use my own private ASN for this MCR. So I'm just going to plug in my ASN here. I'm just going to choose next, add MCR, click order. And so that is going to kick off the deployment of this Megaport Cloud Router, which is essentially, it's a virtual network router that's hosted on Megaport's compute and hypervisor platform. And now I can take, from a connectivity perspective, I've got two services here. I've got my MCR and my port. So as I showed in the diagram, I want to build my cloud connectivity from my MCR. So I'm going to first go and select my AWS tab here, which is going to bring me to the next section, which is going to allow me to choose the type of AWS Direct Connect. Now, AWS has a few different options for Direct Connect. In this case, I've got the choice of a hosted VIF or a hosted connection. There's differences in each one, but for the purposes of this demo, I'm going to choose a hosted VIF. And this is where I'm going to kind of drill down and select where I actually want to deploy that peering with the AWS Direct Connect side of the connection. So as you can see, we've got multiple options here to connect to US East and Northern Virginia. And even in the, even looking at the locations, you can see I've got Reston, I've also got Ashburn. So that could come into play again from a high availability perspective where I can actually build a second direct, or if for some reason there's an issue in this data center at core site with the peering with AWS, the benefit of the Megaport platform is I can quickly just go and spin up another peering through my through the Equinix data center. So just wanted to kind of point that out from again, it's not just the ability to build these connections and scale them up and down, but the underlying physical infrastructure that Megaport has and where it's positioned geographically is really important when it comes to building in resiliency.
Yeah, and this really also dovetails back into how you're kind of hardening your attack surface. You're essentially building these private interconnects that bypass the public internet, as many of you are aware, and it gives you that capability to go direct. So you're getting all the cost saving benefits from doing that. You're getting the scale from being able to pick and choose as you need to with these different environments, and it's all through our purpose-built private network.
Yeah, and so I've got a couple more steps to finish this connection. Again, I'm going to give it a name, and for the purpose of this demo, I'm just going to make it a 50 meg connection. But as we've said, this bandwidth we can come back here and scale this bandwidth up if necessary. Last thing here, I do need to put in my AWS account information, and then I also need to provide my ASN, which is on the Amazon side, which is my Direct Connect gateway. And then the last two pieces of info are the BGP authentication key and the point-to-point subnet information for this particular peering. And the benefit of the Megaport Cloud Router and our integration with the cloud service providers here is, it's going to automatically deploy this and through the APIs with Amazon. All of that is going to be configured for me. So now I just kicked off the deployment of this Amazon Direct Connect. Next thing I'm going to do, because I have Azure, I want to go through the same process. So Microsoft Azure and their Express Route, the workflow is a little different, but conceptually it's the same process. What I have to do in Azure is create the actual Express Route config on the Azure side, and I specifically say where I want this Express Route to be located from a peering perspective, and specifying the Washington DC area. But what I really need to finish the deployment is this service key. So I can just simply copy this and go back to my Megaport portal and go in and add a new connection. I'm going to choose cloud, and I'm going to go and find the Microsoft Azure section, and I'm just going to drop in that service key. And so the Megaport platform is going to recognize that service key and see that it's associated with my Azure account. And it also is going to show that, all right, this express route is already predefined to be peering in Equinix in Washington, D.C. So I'm going to select this connection here, choose next. Again, I can give it a name. And in this case, I've already predefined the bandwidth on the Azure side, so it's already defined here in the portal. I'm going to choose next. Going to kick off the VXC deployment here. Confirm the order.
Yeah. So while that's being validated, whether or not you're deploying this for your own organization or you're a partner that's managing this for your own customer, the journey of being able to do this, you're capturing several elements from different public cloud consoles and being able to orchestrate that all within the Megaport portal. It's kind of the powerfulness of being able to do this from a network planning standpoint, of watching Kevin ultimately deploy these in a matter of a few minutes by instantiating a couple of columns. And part of that seamless experience also speeds up your ability to be able to build out your plan and test things. So whether or not you're running testing and doing tooling, or you have production or mission critical environments, all those unique workloads can be handled within this environment. And you can pick and choose those by VXC, by cloud, and through either ports and or Megaport cloud routers. It's really cool.
Yeah. And, so if I just quickly jump back to my topology here, the last thing I need to do is build this virtual cross connect to, basically tie my, multi-cloud cloud router setup that I just built and tie that into my port. So I'll quickly show how to do that. But I first want to point out, so with the port, you can see it's actually now configured, but the last step that needs to be done is that physical cross connect from my router or network device to the interface on the Megaport side. So the way to make that happen is we've generated, as part of this port configuration, a letter of authorization. So as a customer, you're simply going to take this LOA, contact your data center operator, and the cross connect will be completed. And once that is completed, this port will go to green. It will actually be sending and receiving light through that fiber connection, and then you could start building connections. But I can actually pre-configure that VXC right now through the cloud router. So I'll show you how to build that connection here. So I'm just going to, again, go to connection. In this case, it's going to be a private VXC, which means that, all right, I'm building a VXC between my existing Megaport services, whether it's a port to an MCR, or a port to our other platform called MBE. But so I just need to drill down here and find that port that I created right here. I named it KD port. Choose next. In this case, this is my Dallas to US East. I'm going to give it a specific rate limit from a bandwidth perspective. In this case, I'll give it 100 meg. Choose next. And as you can see here now, I'm actually going to configure the interface on the Megaport cloud router to, the IP scheme between my Megaport cloud router and my physical customer router at my Dallas data center. So I'm going to apply the IP configuration on the Megaport cloud router side. And because I also run BGP in my private cloud, I'm going to actually add the BGP peering information right now. So my peer IP at my on-prem data center, or my colo data center, is this IP here. And then lastly, my ASN that I'm going to assign to the config here on the Megaport cloud router. So I'm now just going to click next, add VXC, confirm the order.
And Kevin, while you're deploying that, a couple of things came to mind. One of the fascinating things about using and instantiating a cloud router is you're avoiding hairpinning your traffic. So if any workload needs to just communicate directly between, let's say, this AWS and this Microsoft Azure environment, and it doesn't need to be routed back to the data center, this MCR can make those decisions. So things like anti-tromboning come into play. So it's the efficiencies, right? It's the efficiencies of your data flows, how you're managing your performance, what needs to come back into that private cloud environment as well. All those decisions can be made dynamically on your behalf using MCR. And the thing that was really interesting about the actual port itself is going back earlier to kind of sourcing, when we looked at some of those insights, that whole procurement cycle, there's no service delivery team involved, which is very traditional and very common in how you're working with different carriers to try to connect. You're kind of waiting on a team to be able to hand you that LOA. You don't have to do that anymore. And that's another thing that's really powerful about this console is you can save time. So you're going from days versus weeks and months on potentially deploying and fully provisioning these types of environments. So it gives you way more control from a deployment perspective.
Yeah, and even another point here, you can see all of my services here in the portal, and these numbers here, this is what we call a service identifier. So when it comes to actual support, if you have an issue with this particular connection or this MCR, this service ID, our SDN, like this is our entire support organization is driven around this too. So they can quickly look at this service ID and map that to the physical Megaport, network devices and physical connections that service identifier is associated with. So I know from past experience dealing with carriers and just even trying to find a circuit ID and opening a case with a service provider can be a really painstaking process. So it's just another element of the software defined platform and not just being leveraged for deploying the connectivity, but also the ongoing management and support.
Awesome. Well, Kevin, I think we have a question in the chat. Going to read it off to you. How are bandwidth adjustments made on a Megaport connection?
Oh, yeah, absolutely. Let me just jump right back into the portal here. So I can simply go into a particular VXC like this one that I built between my Dallas on-prem and my Megaport cloud router. You can see here, these are the parameters. So my bandwidth right now is set to 100 meg. Let's say I need to bump that up to 500. So I'm simply just going to enter that in and save it. It's going to tell me what the difference is in price, but I just need to accept it, and I'm done. So it's literally the same concept of going into a switch port and upping the port speed, upping the bandwidth, or your QoS parameters. It's literally that simple, and it takes the actual implementation of it is as quick as what I just showed you. So now that port is actually set, or that VXC is actually set for 500.
Great. Another question that came in is, will we get access to this recording? Absolutely. This is just the first session of a mini series to come for Megaport Live, and this plans on being hosted publicly. So absolutely, you sure will. So Kevin, was there anything else that you were going to showcase within the portal, or do we need to move on to the next visual?
Yeah, I mean, just to, let me go back to my diagram. So literally what I just deployed was, everything in red here. These red lines represent our VXCs. I built the private VXC between Dallas and my US East region. I deployed the port, Megaport Cloud Router, my Azure Express Route, and my AWS Direct Connect. And it was literally that simple as far as what I just showed you. So just thinking about that and, what the results are of this, as Misha said, you've got optimized traffic flows between Azure and AWS, as well as back to your multi-cloud environment. You can scale this bandwidth up and down as needed, but also as you are evolving and you realize you need more of an HA architecture, you can incorporate that into this design as well. And then adapting to future requirements, whether it's a change in your cloud strategy or even something like an acquisition where maybe you've acquired a company that's based in the West Coast of the US or maybe even in Europe. You could actually build a VXC through Megaport's backbone from Europe, land it on this cloud router, and now you've got a global long haul link between Europe and your US East platform, and essentially do that just as quickly as what I showed you here.
Yeah, I think that's a great leading example. So, whether you're going through a merger and acquisition, whether you're doing a consolidation, whether or not you want to test something new, there's so much appreciation towards some of the legacy technologies that perform really well, such as MPLS, as we alluded to in the diagrams for middle mile connectivity. But as times have changed, innovation and the evolving service offerings that are available in public clouds and how you can run those with your private cloud environment, it becomes so much more powerful to align your operational model, your strategy, especially around networking, with things that give you that agility and that scale to do so through interconnection and being able to do it privately. And that's really the fundamentals to SDN and Megaport's network as a service. And this diagram, it really represents a scenario. And it just so happens to be hybrid with multiple clouds involved. You can fan off multiple connections from your data center through these things called VXCs, these virtual cross connects. So there's so many ways to uncover so many use cases, but that gives you the control and also the security and the performance kind of really at hand for you. So Kevin, I think you did also have kind of a high availability disaster recovery kind of primary secondary architecture that you wanted to touch on as well, I believe.
Yeah, I've got this diagram here, and this is, more of a high level architecture, but, just wanted to kind of point out, for customers that are really involved with multi-cloud and how they can build in this diversity. And this goes back to when I created the port, I had that option of creating a diverse pair. So what we call is at Megaport, we've got a red zone and a blue zone. And what that means is you've got two separate physical cross connects that are going to two separate physical Megaport devices. And then from there, you can then extend that to, in this case, the two Megaport cloud routers. And each one of these cloud routers would be likely hosted in a separate physical data center. And so then from there, each cloud router is going to connect to each cloud. So if you look at, eliminating single points of failure, we've got the ability for customers to do that using our platform. And also in some cases, the cloud providers like Azure with their ExpressRoute, for their SLA specifically with ExpressRoute, they actually require you to have two different ExpressRoute peerings. And that's purely for the Azure side of the SLA. So, being able to meet those types of requirements and leveraging the tools like the Megaport Cloud Router, even the fact that MCR, it runs BGP and things like Q&Q. You can do route filtering, a lot of other BGP functions. And in some cases, customers might not have the physical network devices that can support that. And this basically solves a lot of problems for them without having to invest in, any kind of physical infrastructure.
Great. Yeah, and I think for everyone, whether you're just starting in your new cloud journey with public clouds, or you've been immersed in this and you've been, accessing different workloads for quite some time, any questions around specifications, requirements, different types of architectures and use cases, or just ideas, we're always open, and you have folks that would work directly with you to uncover what it is that your practice is trying to achieve. We're absolutely here to support those initiatives. I think Kevin, did you have anything else, or do we want to open it up for a bit of Q&A?
Yeah, no, I think I covered everything I was planning to cover. So yeah, I'd be happy to take more questions.
Okay, excellent. So everyone, we're going to move into a Q&A form. So if anybody has any questions, feel free to put them into the chat box, and we will give it just a few minutes and see if we can provide you any great feedback. Let me go open that up. So I do have another one in here. Is it common that customers deploy more than two clouds? So just really quickly, absolutely. We see quite a bit of organizations that are using more than two public clouds across our fabric worldwide. And as Kevin had just showcased, in more of a high availability architecture, this is just a leading example of 3 public cloud providers being used. Whether that's, could be for advanced native capabilities. They may have a unique platform as a service where you're really bringing your data to them, but you're using their software, their licensing, and their support to run that platform. Autonomous database is a big one. How you're managing storage, and even the scale of their different types of compute and high performance computing. There's just such a wide area of different ways to leverage, these big public cloud providers. But we absolutely see it being very common that even more than 2 are being used. And that could be cloud to cloud for organizations that are born in the cloud, as well as what we've showcased in this first session of the Megaport Live series, where you're running that also hybrid with your co-location environments in your private cloud. So absolutely. Let's see. Does the cloud router extend to MPLS into cloud? So that's a fascinating question. So the cloud router, so MPLS, you can bring it to Megaport. So essentially it could terminate to a Megaport. And then the layer 3 traffic can absolutely be interconnected to communicate with a Megaport cloud router.
Kevin, you're on mute.
Yeah, you're on mute if you want to add.
Sorry, guys.
Sure,
Sorry about
no worries.
that. Yeah, and just to add to that, for if you wanted to extend your existing MPLS network into the Megaport fabric, it would look similar to this from a topology. Only the customer rack in this case would be your MPLS provider if they have a provider edge router, near that data center, and essentially it would be a cross connect to a Megaport, and then from there it would connect into the Megaport cloud router. So that is absolutely a possibility.
Okay, everyone, how do I connect my network devices to Megaport from my on-premise data center or offices? So there's a couple few different scenarios there. I'm more than happy to chime in, but Kevin, if you wanna take that, I'm more than happy to add in.
Yeah, and that actually is similar to the MPLS question, right? Let's say a customer has an on-prem data center, but they're geographically close to a Megaport data center. They could bring a point-to-point connection from their on-prem and land it in a Megaport data center, and then have that connection there. So that's how they would extend using a private connection. The other method is what we call the Megaport virtual edge. So we didn't cover that in today's session, but what the Megaport virtual edge is it's almost identical to what the Megaport cloud router is, except it can host third-party virtual appliances. So something like a FortiGate appliance or a Cisco appliance, Aruba, VMware, Versa, soon to be Palo Alto. So we can host these third-party appliances the same way we host our cloud router. And then the key difference is that we're also going to provide internet transit mapped to a virtual interface on that router. So what that does is it gives the customers the ability to leverage their existing internet transport at their remote site, their headquarters, take advantage of building an SD-WAN connection or an IPsec connection over the internet, which would very likely be within a low latency region, because we can host this in multiple locations. But essentially, that is the alternative method of tapping into Megaport's network, is through what we call the Megaport virtual edge.
Yeah, and just to lightly add to that, think of the Megaport virtual edge is really us exposing our edge to the public internet. So you're essentially just a single hop off the public internet in a localized metro, and we host where we open up our edge in dozens of locations worldwide. So then the proximity of you getting in, you're dealing with low latency, you're able to hop right off the public internet onto our private edge, and then everything is fully private from that point on to any destination on our fabric, on our network. And as it relates to other additional data centers, we have so many to choose from. There's hundreds of sites, and we have a really great locations tab on megaport.com, where you can go and see where we physically have our network or we have an extended data center. So I always encourage you to take a look at that as well, because if you are in a co-located environment and it's not just your on-premise, your own unique data center or office, then we may have an extension to you already. So it's great to look at the location list, and that will also tell you where MVE also lives. So you could use, to Kevin's point, any of these SD-WAN vendors and bring your appliance, your license to our edge, and then we'll deliver a very streamlined experience and solution for you. Let's see here. I believe that is all the questions. So if nobody has anything else, I'll give it back to you, Juliet. And Kevin, thanks for going through the demo.
Yeah, thank you. Appreciate it. Appreciate everyone joining.
Thanks, Kevin. Can you just move to the next slide? Or the next one after that? There you go. Thanks. So thank you for taking the time to join us today. This is our first webinar, as Misha mentioned, in our new live series. We'll be hosting these at least once a month. So keep an eye on LinkedIn, Twitter, email, and our website for upcoming topics so you can register and join us again. If you have more questions or would like a member of our team to contact you, please complete the form that I put in the chat panel. And it's also available here on the bottom of the screen. When you close out of the webinar today, there's going to be a short survey that will pop up on a new tab, and we'd really appreciate if you would complete that for us. We want to bring forward topics that are in this series that are meaningful to you. So your input is extremely valuable to us, so that we make sure that we bring topics that are what you want to hear about. So thanks again for joining. I will now close the call, and thank you.
Great. Thanks, everyone.
Thank you.